Okay. So in the last lecture, we have seen some laws of Boolean algebra, right? Yes or no?
Yes, ma'am.
Yes. After Diwali, I think this is first lecture of electronics, right? So today we'll quickly revise all the rules. Who is this Ajinkya Karade? What are you doing? Clear the screen immediately. Clear the screen immediately. Okay. So Boolean, we have seen some laws of Boolean algebra in which we have seen some Boolean enzymes. What are enzymes? The operators, you can say, right? First one is your dot sign, which is all used for the multiplication. That can be also expressed as cross. That is again multiplication. That indicates the product of two terms. Simple. If I'm saying multiplication, it will obviously going to take a product of two terms. After dot, we have second sign is plus sign. Correct. Plus sign indicates the logical sum of two terms. If I said a plus b, that indicates we are going to add a and b, right? So or operation is nothing but your addition operation. That is why it is also pronounced as, or it is also read as a or b. Okay, if I'm writing it like this, a plus b, I can read it as a or b, right? And the third and very most
Ma'am,
important, yeah.
ma'am, your voice is so low. I'm not getting to hear it.
Why? Okay, just let me connect another headphone. All right. Now I'm audible all? Audible to all?
Yes, ma'am.
Is the voice okay now?
Yes, ma'am.
All right. So the next one is your the main parameter or the main enzyme you can use in this boolean is nothing but your overbar, right? Overbar is nothing but you can simply call it as a bar, right? Whenever I'm writing a and a bar over a, it will be pronounced as a bar or complement of a, right? So it is nothing but the inversion or the complement of a, right? After that, we have seen some rules of addition and multiplication. Kannada madam. So we have seen some rules of addition and multiplication, right? In addition, we have seen that like these rules are very common to all. Correct? 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is again 1. We have seen this. Multiplication is also, if I'm multiplying 0 with any other number, my answer will be 0. Correct? And only 1 into 1 will be my 1. Everyone is clear with this? These are the simply rules of addition and multiplication. Correct? Yes? Just give me the feedback. You're getting it or no?
Yes, ma'am.
Yes,
Yeah,
ma'am.
we are just revising. That is why I'm going with fast speed. It's not. I'm not going to explain each and every term because we have already seen this and we are just revising it. Correct. After that, these are the rules and laws of the Boolean algebra. First law is your law of intersection. Intersection is about multiplication of a variable with the one. Okay, a is my variable. If I'm multiplying a with the one, y answer will be a only, right? And this is the logic diagram for that. Okay, what is this logic diagram? There is a multiplication dot, correct? Dot represent multiplication, and for multiplication, which gate we use? Which is this gate?
And gate.
AND gate, right? For multiplication, we are using AND gate, and which two inputs we have? A and 1. So AND gate will have input A and AND gate have input 1. Correct. Multiplication of them will be the output of AND gate. Simple as that, right? This is nothing but your law of intersection of multiplication. Now again we have to see the law of intersection for the multiplication only, but with the zero. Correct. If I'm multiplying any variable with the zero, my answer will be zero, because no matter what is your variable, if you're multiplying that variable with the zero, the answer is ultimately zero only. Correct. Now next one is your law of union. What is union? Addition of 1 and 0. Now see, if I'm adding my variable with the 1, okay, variable plus 1, answer will be 1. How to do this, or how to prove this? For addition, which gate we are going to use?
OR gate.
OR gate, right? So this is my OR gate, and which are the two inputs we have? A and 1. So OR gate have input A, OR gate have input 1, and the addition of them will be answer 1. Correct. Now how to prove this? Na? Simply I can just say, if I put A is equal to 0, and if I put A is equal, the second input is 1, 0 plus 1, what will be my output? 0 plus 1.
1.
0 plus 1
One.
will be always 1
One.
only.
1.
Okay. If I put that variable A, which is equal to 1, then in that case, what will be my output? If I put this is equal to 1, then 1 plus 1 will be, in Boolean, what will be 1 plus 1?
1.
1
One.
only. Correct.
One.
That
One.
is that is how this can be proved, right? After that, this is the second law, in which we have the variable which is going to add with the 0. No matter what is the variable, if we are adding 0 to it, the answer is going to remain same only. Correct. This is my variable and I'm adding 0 to it. Will there be any change? No, right? The answer will
No.
be variable itself. Correct. After that, if a logic 0, no, we are not going to see this. This is just an explanation what I just told you. After that, there is a law of tautology. What is tautology? Variable multiply with the variable only. Okay. What is A? If I consider A is equal to 1, answer, like the question will be 1 into 1. The answer will be 1 into 1.
One.
One.
Answer will be 1 only.
One.
Correct. If I have A is equal to 0, 0 into 0, in that case, answer will be
Zero.
0. Right. So you're getting it. No matter what is your variable, if you multiply the same variable with the same another variable, see, I consider A is equal to 1, and I'm multiplying A with the A only. So that is 1 into 1. The answer will be same variable. Or I can consider A is equal to 0. If I'm multiplying 0 with the 0, my answer is 0 only. Correct? So this is nothing but your law of tautology. After that, this is the addition law of tautology, in which we have two variables and we are going to add them. We are having single variable and we are going to add it with the itself. Right? So A plus A, 1 plus 1. What will be my answer?
One.
1.
1.
After that, 0 plus 0. What will be my answer?
0.
0
Zero.
only. So no matter what is my variable, if I'm adding the variable with itself, the answer is variable again. Right? Understand? Next is your law of complement. You can ask me if you're not getting any of the law, right? Because these laws are very important and we are going to use these laws throughout the entire syllabus, right? After that, law of complement. You don't need to remember the name of the law. Like, you have to, but it is not compulsory, but you should know what is this. Okay, if I'm multiplying A with the its own complement, what will be my answer? You should know this at least, right? So A into A bar. This is law of complement. What is complement? What is complement? Can you please tell me? Anybody?
Inverse of the real value.
Correct. So whatever the variable we have to we have to take inverse of that. What is inverse? What is inverse?
Napane.
No, not in that term. Here we in case of digital, what is inverse? It is an opposite
Opposite.
term. Correct. If we have 1, the inverse will be 0. If we have 0, the inverse will be 1. This is how it is. And it is also called as complement, or it can be represented as a bar, right? Now, what we have to do, we have to take the variable a. If I consider, I take a is equal to 1. A dot. What is a bar?
0.
0.
0.
Okay. So, what will be the answer?
0.
0.
0 only. Correct. So 1
0.
into 0
Yes,
is
ma'am.
0 only.
0.
कोणाचा बॅकग्राऊंडला आवाज येतोय रे? खूप डेंजरस आवाज येतोय गाड्यांचा. Anyways, so if I consider, you have understood this, right? If I'm multiplying any variable with its own complement, the answer will be 0. We can prove it in the another case also. If I put a is equal to 0, what will be my a bar? If I have a
1.
is equal to 0, what will be my a bar?
1.
1. Correct. So 1 into 0, 0 into 1, again it will be 0. Right. So this is how this law is proven. Like if we are multiplying a variable with its own complement, the answer will be 0 only. Right.
Yes, ma'am.
Okay. So again, the law of complement for the addition, it will be single variable a is get added with the its own complement. Right. If we consider a is equal to 1 plus, what will be a bar?
0.
0. Simple as that. What will be a plus 0? Oh, sorry, 1 plus 0 then?
0.
1.
1.
1.
1.
Right. Now this is proved. Right. We consider variable a is equal to 1. And if we are adding that 1 with its own complement, that is 0. 1 plus 0 is your 1. Now if I consider a is equal to 0, 0, what will be a bar?
1.
1.
1. What is 0 plus 1?
1.
1.
1 only, right? This law is proved, right? So this is how you have to prove each and every law. So if for the remaining laws, I'm not going to prove each and every, I'll just state it, right? This is the law and this is the answer and this is the logic diagram. Logic diagram everybody is aware of. Whatever is the sign used in between, the same gate you have to use. If there is a dot, you have to use AND gate. If there is a plus sign, you have to use OR gate, right? The two inputs you are going to have and the ultimate output, single output you will have, correct? Now, the law of double negation. Double negation is what? First of all, what is negation?
Negative form.
You can say complement, right? So, negation is what? Negation of A is nothing but A complement. Okay. Double negation of A will be double complement, right? So, this is double negation. A double bar. So, how to represent this? Okay. A double bar. Which gate we used for the to represent the bar?
XOR.
Which? Which gate we use to represent complement or bar
NOR.
or negation?
NOR.
No,
NOR. Not.
not gate. Try to understand the things. Try to remember the logic gates. Okay.
Not yet.
Huh. So this is what is your NOT gate. What we have a bar first, right? How to represent a bar? This is how, right? If I'm applying input a here, a NOT gate, I'm getting a bar here. But do I want a bar? No, I want a double bar. So what will I do? I will put an another NOT gate here. Okay, what will be the output of this NOT gate?
A.
A
Double
only.
bar.
It will be A only, but this is the bar which is already have, and because of this NOT gate, we will have double bar. The A double bar is nothing but A only. Correct? So A double bar is nothing but original variable itself, A. Right? आता तुम्ही example घेऊन solve करू शकता हे, so that you will understand it much better. Okay, consider what should we consider a is equal to either 0 or 1. What you want?
0.
Okay, ठीक है. I'll consider a is equal to 0. Right? What will be the output at this point?
1.
1.
1.
this 1 is applicable as an input to this NOT gate, correct? Now what is the output of this NOT gate?
0.
0, right? So what we perform? Double negation. How? We uses two NOT gate. Okay, after using two NOT gate, what I am getting at last? 0, which is the same variable, right? आपला input काय होतं? 0, and I am getting output is also equal to 0. So double negation is nothing but original variable itself, right? Understood?
Yes, ma'am.
Right, good. After that, this is the law of commutation, in which A dot B is equal to B dot A. This is simple. Like तुम्ही हे 7वी 8वी 9वी 10वी ला कुठेतरी शिकला असणार हे सगळे laws. So I'm not going to repeat this again because we have already seen it. If you missed that lecture, you can visit the YouTube link, right, which I already provided to you. Okay. Now this is for multiplication. A plus B is equal to B plus A. Again, this is a simple thing. If I'm adding 2 plus 3, the answer will be 5. If I add 3 plus 2, answer is again going to be remain 5 only, right? So that is not the change. There will not be any change. Law of association. Again, this law, remember this. This is important. A plus B in bracket plus C. Correct? And A plus B plus C, which is equivalent to A plus B plus C, right? So no matter where is the bracket, the answer is going to remain same. If I put 1 2 3 value of A B C, if I put value of A, and A is equal to 1, B is equal to 2, and C is equal to 3. So what will be the answer? See, A is equal to 1, B is equal to 2, C is equal to 3. 1 2 3. What is the answer of this first term?
6.
6. And what is the answer of second term?
6.
6 only. So both the terms are equal, right? This is just for your understanding. In Boolean, we are not going to use any other number other than 0 and 1. Correct. After that, they just implemented this equation with the help of logic gates, right? How many number of logic gates we are going to require to implement this first equation? Can anybody tell me? Just to implement first Boolean equation, how many number of logic gates I am going to need?
2.
2.
Which two? Which
Or
gates?
gate.
Both will be my
Or
OR
gate.
gate. As no, it will not be or not gate. It will be OR gate only, because for addition we have to perform addition, right? And for addition we are using OR gate. Two OR gate will be there. Similarly here also we have two additions. So again we need two OR gate, right? See the second law, in which we have the same thing, but there is a multiplication instead of addition. Here we have addition. See, there is an addition, and here we have multiplication. This is what is the difference, correct? And you have to implement by using the logic gates. How many logic gates you are going to need?
2.
Two, right? And for multiplication, which gate? Which is this gate?
And gate.
And
And
gate,
gate.
right? Law of distribution. Now next one is your law of distribution. What is distribution? A in bracket B plus C. What it will be? A simplification. A will get to remove the bracket. First of all, by seeing this equation, we have to solve it, or we have to minimize it. How to minimize it? By removing the bracket. After removal of bracket, what it will be? A will get multiplied with B plus A will get multiplied with the C. So AB plus BC will by AB plus AC is my answer. Correct? And we have to implement that using logic gates only. Simple. You getting it? We are left with the 10 minutes only. Just
Yes, ma'am.
respond quickly. How many pages we have? We have too many pages. So we'll do one thing. Okay, we'll revise here only, na? Where were we? We have seen this example, right? A dot B dot C. No, not this. Which example?
Distributive.
Ha. No. This only. A dot B into C. So what it will be, it is exactly equal to, if I just move the position of bracket, if I put the bracket here, the answer is going to remain same, right? The next one is your law of distribution. So in case of law of distribution, what it will be, a in bracket b plus c. So this okay, exactly this I explained you. A will get multiplied with the entire bracket, and that will be ab plus ac. Correct. Dot represent multiplication. If I write ac like this and there is no sign in between, what does that indicate?
Multiplication.
Multiplication.
Correct. So that will be multiplication. So this is what it is. Now the second law is what? It is a plus b dot c. Now what will happen? Again, this a will get multiplied with the entire bracket, but there will be a multiplication. Correct. So a plus b will be my first term, dot a plus c. Understand? Now, law of absorption, in which we have a plus a dot b. So there is a proof for all this. Correct. We have seen all the proofs. Remember or no? See, we have used Boolean equations. We have used Boolean logic rules. Correct. So I'll share the link of previous video again, and everyone just go through it. Okay. For today, what I have is, mm, where is that? So we just finishes the entire lecture to revise and last thing. Oh. Okay, so this is the new thing which we are going to study today. We have to study the universal gates. Okay, and which are the universal gates? NAND and NOR. I have shared that presentation in which everything about the logic gates were listed. Correct. NAND and NOR are the universal gate. Why these are called as universal gate? The very basic question. It is asked in the, like, they asked this question in the exam. Why universal? Why NAND and NOR called as universal gate? What do you think? Why it will be called as so? Any specific reason you are aware of? Hmm? Anybody? Am I audible? The lecture is going on. Hello.
Yes, ma'am.
Hello.
अरे बोला ना
Uh,
मग असं का बसलात? हो नाही काहीतरी बोलायचं ना असं अजिबात बसून राहायचं नाही या. So NAND and NOR
okay,
gate are
ma'am.
called as a universal gates because you can achieve function of any other logic gate. Right? What I'm saying is नीट लक्ष देऊन ऐका. This is important. NAND and NOR, these two gates are called as a universal gate because they can, because using the NAND and NOR gate we can achieve function of any other logic gates. म्हणजे काय? If I want to implement OR gate, okay, what is OR? Addition. Okay, by using these two gates I can perform the addition operation. I can perform the operation which OR gate do. ओके, म्हणजे काय, बेसिकली नॅन्ड आणि नॉर गेट वापरून तुम्ही कुठलंही गेट बनवू शकता. दॅट इज वाय दे आर कॉल्ड एज युनिव्हर्सल गेट. Everybody is getting the point. What I'm trying to tell is,
Yes, ma'am.
right, by using
Yes,
the
ma'am.
universal gates NAND and NOR we can achieve the function of any other logic gate, and that is why they are called as universal gates. Now see how to achieve such. Now we have, first of all, we have to achieve a NOT gate, but we have to use only NAND and NOR. Now what to do? This is my NAND gate, this is my NOR gate. Correct? And what I have to perform is NOT gate. Right? Now see the diagram. This is the basic diagram of NOT gate. Right? A, there is a triangle shape, there is a bubble, and we will have A bar at the output. Right? So this is your NOT gate. How to achieve this by using NAND gate? See this diagram. You aware of the NAND gate, right? लॉजिक गेट्स आठवतं ना सगळ्यांना
Yes, ma'am.
की नाही
Yes, ma'am.
आठवत आहे? खरं खरं सांगायचं मला, आठवतंय की नाही आठवत आहे?
Yes, ma'am.
Okay, so this is my NAND gate. Okay, this is how NAND gate looks like. So this is a bubble and there will be an output. Correct. This is how my NAND gate will look like. Now, if I just provide single input, if I just short both of them and if I provide one input to that, this is how my NOT gate will perform. How? See, we will see. If I give input is equal to 1 here, what will be the answer? बोला पटकन चला.
0.
How?
Inversion, ma'am.
Correct.
Inverse,
So
ma'am.
आपण इथे 1 apply केलंय. That 1 will go at here and here also. What is the basic property of NAND gate when both the inputs are high?
Output is low.
When all the inputs are high, the output of NAND gate will be low. झालं का तुमचं NOT गेटचं ऑपरेशन? इनपुट 1 दिलं होतं, आउटपुट 0 मिळालं. पण वापरलंय काय मध्ये तुम्ही? NAND गेट वापरले. ऑपरेशन कोणाचं झालंय? NOT गेट झालंय. म्हणजेच काय? बाय युझिंग NAND गेट यू कॅन अचीव्ह द फंक्शन ऑफ NOT गेट. NOT गेट वापरलंय का इथे कुठे? मला सांगा. आपण NOT गेट वापरलाय?
No.
No. Still we are getting the operation like NOT gate. Input will be 1, input is 1, output will be 0. Correct? सगळ्यांना समजलं का how to achieve a NOT gate by using NAND gate? काय केलं हे? की नाही समजलं? बोला पटकन चला. नसेल तर नाही म्हणा, हो असेल तर हो म्हणा, सिम्पल. हा? अरे समजलाय का? Now we have to achieve same NOT gate by using NOR gate. Okay, NOT gate NOR gate वापरून तुम्हाला काय करायचंय? NOT gate achieve करायचंय. In that case, see. This is how my NOR gate will look like. If I apply 1 at its input, it will be 1 1. And in case of NOR gate also, when both the inputs are high, output is always true. And I'm getting 0 at the output. So after application of 1 as an input, I'm getting 0. So that is the basic operation of NOT gate. समजलं आहे का? दोन्ही पण गेट. पटकन बोलायचं, नसेल तर नाही म्हणायचं. आय कॅन रिपीट. शांतपणे बसून राहिलेत ना, लेक्चर बंद करून टाकेल. तुमची तुम्ही सेल्फ स्टडी करायचा.
नाही समजलं मॅम.
नाही समजलं मॅम.
मगाशी 4 वेळा विचारलं ना मगाशी.
No, ma'am.
तेव्हा नाही सांगता आलं. 4 वेळा विचारते समजलं का, समजलं का, समजलं का, तरी गप बसलेत आपले. नशी व्हॉट तुम्हाला करायचंय काय हे तर समजलं का? आपल्याला वापरायचे कुठले गेट आहेत? फक्त NAND आणि NOR. Okay, we are using only these two gates. By using these two gates, we are going to perform the operation of other logic gates. Which other? NOT and NOR. बरोबर? हे 2 गेट वापरून आपल्याला हे 3 गेट बनवायचे. समजलं? बेसिक आपलं एम तर समजलं का? करायचं काय आहे? व्हॉट इज द टार्गेट?
Yes, ma'am.
Now, what we are
Yes,
going to
ma'am.
do, first of all आपण नॉट गेट बघूया. नॉट गेटचं फंक्शन काय? जे काय इनपुट देणार आहे त्याच्या अपोजिट मला आउटपुटला मिळतं. करेक्ट? सो वी हॅव टू अचीव्ह दिस थिंग विथ द हेल्प ऑफ NAND गेट. करेक्ट? सी असे इथं दिलेले डायग्राम ड्रॉ केलेलं आहे. NAND गेट ऍज नॉट गेट म्हणजे काय? नॉट गेटचं फंक्शन आपण अचीव्ह करणार आहे विथ द हेल्प ऑफ NAND गेट. Right? See, this is my NAND gate. NAND gate will have 2 inputs. Correct? आपण काय करायचं, दोन्ही इनपुट शॉर्ट करायचे, एकमेकांना कनेक्ट करायचे आणि तिथे तुम्ही एकच इनपुट देणार ए. म्हणजेच काय झालं, हे ए जे इनपुट आहे ते इथे पण आलं आणि इथे पण आलं. कळालं? Consider we have given a is equal to 1. So this 1 will come to this portion also and this portion also. Am I clear with this?
Yes, ma'am.
Yes, ma'am.
Okay. Now, what is the logic table or truth table of AND gate? Sorry, NAND gate. आठवतोय का NAND गेटचा ट्रूथ टेबल? आठवतोय का? एक हो किंवा नाही सांगायचं फक्त. नसेल तर मला सांगायला आणि पुढे जायला. आपल्याला टाइम वेस्ट नाही करायचा आहे. ट्रूथ टेबल आठवतोय का NAND गेटचा?
No, ma'am.
सो आता सगळ्यांनी काय करायचं, एक तर कोणीतरी फक्त
Yes, ma'am.
एक जण नाही म्हणालाय, इच अँड एव्हरी वन लॉजिक गेटचा नोट्स प्रिपेअर करायचा. सेकंड चॅप्टर जिथपर्यंत शिकून झाला, दिस इज व्हॉट इज युअर सिलेबस, गो थ्रू दिस. ओके, इथपर्यंत सिलेबस शिकवून झालेला माझा. लॉजिक गेट झालेलं आहे, सीमॉस टीटीएल लॉजिक फॅमिली झालेलं आहे, बुलियन अल्जेब्राचे लॉज झालेले आहेत. करेक्ट. सो मला तिथपर्यंतचा नोट्स कम्प्लीट पाहिजे तुमचा, कारण मला माहिती एवढा मोठा टाइम गेलाय मध्ये, कोणाला काहीच आठवत नाहीये. त्याच्यामुळेच ही अवस्था आहे लेक्चरला. सो व्हॉट फर्स्ट थिंग आफ्टर दिस टुडेज लेक्चर व्हॉट यू आर गोइंग टू डू, मी तुम्हाला ते लिंक दिलेली आहे, बरोबर? आठवतंय का तुम्हाला? दिली आहे की नाही जुन्या व्हिडिओची?
Yes, ma'am. Yes, ma'am.
ते चेक करायचंय.
परत एकदा पाठवा ना. परत एकदा टाक ना.
हा, परत टाकते मी. ते सगळे व्हिडिओ चेक करायचे. आपल्या जेवढे लेक्चर आहेत ना, सगळे लेक्चर्स आहेत त्याच्यावर. तर प्लेलिस्ट मध्ये बघायचं, FYBCS म्हणून तुमचं फोल्डर आहे, त्या फोल्डर मध्ये तुमच्या सगळ्या लिंक्स आहेत. सगळ्या लिंक बघायच्या आणि मला सेकंड चॅप्टर रेडी पाहिजेत, म्हणजे पुढचं शिकवायला. मागचंच काय आठवत नाही, पुढचं काय शिकवणार आहे. ठीक आहे. सो व्हेरी फर्स्ट थिंग आफ्टर टुडेज लेक्चर व्हॉट यू आर गोइंग टू डू, यू हॅव टू कम्प्लिटिंग द नोट्स. लॉजिक गेट्स इच अँड एव्हरीथिंग इन डिटेल्ड पाहिजे मला, जसं मी शिकवलं होतं तसं.
Yes, ma'am.
See, I'll tell you. FYBCS 10. आता हे रिफ्रेश्ड नाही, आय गेस याच्यामध्ये जास्त व्हिडिओज आहेत. पॅरामीटर्स ऑफ लॉजिक फॅमिली, कन्व्हर्जन, BCD 7 सेगमेंट कन्व्हर्जन. कुठे तुम्हाला लॉजिक गेट्स पाहिजे होतं ना? बुलियन अल्जेब्रा इथे. लॉजिक गेट्स याच्यामध्ये नाही, मी ऍड करते. लॉजिक गेट्स आहे आय थिंक. सी, हेच लॉजिक गेट्स तुम्हाला पण यूज करायचंय. SYBSC जे फोल्डर आहे, तुम्हाला ही पण लिंक शेअर करते मी. समजलंय? कोणाला काही डाऊट आहे? लेस दॅन 1 minute इज लेफ्ट. आय विल शेअर द लिंक विथ यू गाईज. आणि रिव्हिजन कम्प्लीट करून यायचं उद्याच्या लेक्चरला, असं ब्लँक यायचं नाही.
Yes, ma'am.
Okay. The lecture can end at any time because less than 1 minute is left. Can you say this time? हे दिसतंय का सगळ्यांना टाइम किती राहिलाय की नाही दिसत आहे?
नाही दिसत.
अच्छा, ओके. Anyways, so I'll share the link and go through that.